These things should all be possible such that we don't have to necessarily burn an entire US household's monthly consumption of energy just to ask a simple question that you could otherwise Google search.
Hello, and welcome to AI Curious. My name is Jeff Wilser. I'm a journalist, I'm a human, and I'm curious about AI. And here is a dominant story about AI right now, and you know it because you can't avoid it. It's everywhere. The models keep getting bigger. The data centers keep getting bigger. OpenAI is reportedly buying nuclear power. Meta is spending hundreds of billions. Microsoft is reopening 3 Mile Island. Yes, that 3 Mile Island to feed the GPUs. The thesis is everywhere. More compute, more data, more parameters, more intelligence just keeps scaling. My guest today thinks that's only half the story. Not wrong exactly, just incomplete. And the half that's missing in his view is the half that actually reaches most of us. His name is Jeffrey Lee. He's the CEO of Liquid AI, an MIT spinout building a category of model that almost nobody outside the field is talking about. Not big, but small ones, specialized ones. Models that don't live in a data center, they run on the silicon already sitting inside your phone, your laptop, even your AirPods. The thesis goes something like this. Yes, you want a giant cloud model for solving cancer or sending people to the moon, but 99% of the processors on Earth live outside data centers. And if you're a law firm reviewing contracts, you don't need a model that can also write French poetry. You just need one that's really good at tort law. Tailored, in Jeffrey's words, like a suit. Liquid is building those tailored suits. Their research started a decade ago that became Liquid Neural Networks, and that became Liquid AI, which is now the engine powering the new in-cabin assistant to your next Mercedes. We get into all of this. Yes, they have partnered with Mercedes. Jeffrey will share how and why that matters. And we get into why this will especially matter once the AI subsidies finally end. Once AI gets more expensive, every company will soon spend a lot more money on AI, and these small models could be the way forward. And why agents on your devices are about to make the cost math impossible. And the much weirder question underneath all of it, what if the future of AI is not bigger and louder? What if it's smaller, quieter, and everywhere? So with that, please enjoy my conversation with Jeffrey Lee, COO of Liquid AI. Jeffrey, welcome to AI Curious.
Thank you for having me.
So let's start with how you got into this wild world. I think your origin story is pretty damn impressive, and we'll give a little context and perspective for what's about to follow in our kind of exploration of large versus small AI, if you will.
Absolutely. I went to MIT in 2016, and I think it was a great timing because at the time AI was the craze. MIT was rethinking its curriculum around AI. And really, if you look at where the AI world was, we had just had a transformational moment in the last couple of years before that in classical computer vision, so helping computers understand what they were seeing, and the same thing in natural language. The generative models of today didn't exist yet, but we were really at a point where people were starting to deploy even traditional ML systems into production at real scales with real impact. So that was very exciting because what that allowed me to do was I ended up graduating early and rushing into industry. My first job was I was on the computer vision research team at Snapchat, really focused on trying to build real useful experiences, or in this case, fun experiences on phones. So people remember the moment when Snapchat switched from having these static filters to putting a dog nose on your face. That was the team I was working on. Really exciting, really innovative technology we were doing there at the time.
We have you to blame for all that. All of those, all the time wasted. We have you to thank and blame. Amazing. Love it.
Exactly. My personal experience on that team was, look, it was very clear to me AI was this frontier that we barely dipped our toes into. There's so much interesting juice to squeeze. And my personal take was I wanted to be on really the product and innovation side of that. I wanted to think about how we deploy AI into the real world. Being an ML researcher, while it's very fun, the nonlinearity of it and the distance away from the end use case wasn't for me. So I ended up taking a job at a company called Scale AI, which recently got acqui-hired by Meta. Alexander Wang, the founder, is now the Chief AI Officer over at Meta Superintelligence Labs. I joined Scale when it was about 50 people, 90 million valuation, and I was the first hire younger than Alexander. At the time, the company was focused on data labeling for self-driving cars. Not a sexy space at all. We were literally flying people to countries such as the Philippines, setting up laptops, doing scrappy things to get them to label data for what is now, Waymo, et cetera, on the roads. My responsibility there was to make scale. So what does that mean? That means scaling beyond just self-driving data into all sorts of data. So product search data, GPT, OpenAI style data. We labeled menus for food delivery apps at one point, just all sorts of different data. And then also scaling our ability to serve that data. So not having to fly and meet the labelers, but really building an ecosystem and an economy virtually of people who could label and get paid for doing that. So I really enjoyed that because I could think about the real world applications of AI. I could contribute to AI in a more linear way by building the products and infrastructure and the operations required to make that a reality, and still work very closely with researchers. After that, I left Scale. I started a company. That company is called GatherTown. GatherTown raised a Series A and a B from Sequoia, really focused on the metaverse, applied AI, helping companies work more efficiently. It was spawned during COVID when people were displaced and needed new ways of working. That company just got acquired by Figma earlier this quarter.
Awesome. So let's jump into the big question of your thesis of why big AI and so much of AI is bigger, better. We need to just more compute and more data. You're essentially, not to be reductive, essentially saying that's misguided. How would you summarize at a high level the flaw with the primary approach people are taking with bigging these larger AI frameworks?
Fantastic question. My intuition about this really goes back to how humans operate in the real world, right? There's a common framework that people subscribe to, type 1 and type 2 thinking, right? There's moments where you need to...
Daniel Kahneman-esque type 1, type 2, meaning, let me know if I'm getting this wrong, type 1 being kind of the faster, almost impulse, gut reaction, type 2, the more deliberate analysis thinking mode. Am I getting that right?
Absolutely, right? And if you think about why humans are so great at what we do, some would say it's because we're really good at using fast thinking. We're really good at recognizing patterns, not having to, use the same kind of, full end-to-end energy and existential thinking for each small decision, like what to eat for breakfast, right? We're able to recognize patterns, and that's our ability. And that same intuition, I think, applies to AI, which is there are moments where you need this type 2 slow critical thinking for deep research, for science, for solving cancer, for sending people to the moon, etc. But just like with humans, our thesis is you need also the ability to do type 1 thinking, fast thinking, efficient thinking. And as AI gets more and more mature, first and foremost, that ability to swap between those two systems is incredibly important for anyone building an AI feature. And then 2, we also believe that as things get more robust and get more proven and adopted, the percentage of AI workloads that should be handled by type 1 should actually increase. Right? And it means what we think. Oh, I'll pause.
No. That's go on. It's great. You're cooking. Go on.
It means we think that we see them less as competitors and more as different tools for different kinds of thinking that we already see in the real world.
So I want to get a little deeper understanding of this, because I think my understanding is that there's a more fundamental way of a fundamentally different way you're thinking about AI development than many of the frontier labs, including the obvious ones of OpenAI, Anthropic, and so on. And I guess I'd like to hear a little more about how your approach is different, right? Because even I think many listeners here will think, oh, but I see when I go into Claude or ChatGPT, I see type 1 versus type 2 right there, right? It's different
Right.
titles, it's the thinking model or the instant model, right? So they have their ability to toggle between type 1 and type 2. But I think you're describing a more fundamental different approach to AI, one that does not require the extensive data centers and less energy. Talk a little more about that.
Absolutely. And I think type 1 and type 2 exist on the continuum, right? Like even within large data center, high GPU, high energy, nuclear power regimes, you can have heavy models and lighter models. But we think intelligence needs to be everywhere. We think intelligence deserves to be on the 99% of processors that exist outside of data centers. Not to say data centers shouldn't run AI, but why should it be limited to the data centers? We believe that just like computing and the internet and technology reached our fingertips, right? You can have Internet of Things is a trend. We all benefit from it. I have AirPods in my ears right now doing noise cancellation. Similarly, intelligence should be allowed to be everywhere. Does it mean that your AirPod needs to be able to do deep research and solve cancer? No, right? But it means that you need to be able to deploy the right kind of context-aware and domain specific intelligence systems on the compute that matters. And so what Liquid believes in figuring out how to build foundation models, generative AI experiences that deliver the production quality people come to expect when they chat with ChatGPT and Anthropic in the cloud, but allow that to run closest to the point of interaction. So running on the phone when you use the phone, running on your laptop, running in your car, and running on your tractor if you're a farmer. These things should all be possible, and that allows the greatest amount of flexibility for AI use cases to be built, to be useful, to be safe, to be fast, and to be efficient, such that we don't have to necessarily burn an entire US household's monthly consumption of energy just to ask a simple question that you could otherwise Google search.
Yeah, I think that last thing you said is really getting warm and dialed into kind of where I'm going with this, in a sense of love to have a better understanding of the problem, or that a company, maybe we can even take it on two levels. Let's start with kind of at a organization level, company level, and then even like, not to get too grandiose, the world level, right? But at a company level, what are the downsides of using just like, okay, cool, I've got the latest model from OpenAI and it works great. It solves all my problems. Why do I need them? Not solving my problem in the AI way that AI is solving problems, right? It's handling all of my AI use cases. What's the downside of that? What problem with that model are you guys looking to solve and fix?
Amazing questions. It's really about ROI for enterprise. And what does ROI mean for us? It means that AI is a transformative technology. People can build and prototype and imagine, art of the possible. An e-commerce company we work with, Shopify, was able to sit down and ask themselves, hey, if we use these AI models in the cloud and we rewrite every single search query that comes into our system, and we more intelligently refactor what someone's searching for. So when they search up Kevin Durant shoes, we don't just capitalize the K and the D. We actually think about what that means and we create a better query. It turns out everyone has a better experience. That's great. And same thing when we talked to Mercedes, who we just did a deal with. They realized if we use these new technologies instead of the legacy technologies of late, our in-car virtual assistant is much better. JD Power said that the Mercedes car in-car assistant was their worst feature. How can we turn that into the best feature, right? So they all realize this independent of working with us. But where does the ROI calculus comes in? It comes in when they need to deploy these into production. Shopify sits down and does the math. If every single search query has to go to the cloud, go to someone's data center, that's extremely slow. It'll slow down each query by over 10 times. Extremely expensive. Now imagine you have to run millions of queries every single hour through a GPT server. What happens, right? If the servers are slow or the servers are down, the ROI doesn't make sense. Same thing with Mercedes at the edge. Does it make sense for us to send every single user invocation about turn on the windows or I'm feeling a little cold in here to the cloud? What's the cost of that? What's the cost of sending this over a satellite? These things, the speed, the cost, it makes the ROI painful. In addition, there's secondary impacts too, such as violating data privacy, GDPR compliance, etc. And so what we are able to do is by allowing them to maintain that production quality, but do so without the need of a data center, such that it's in a smaller, more efficient, purpose-built model that Liquid, is able to produce with this differentiated way of building models from the ground up to a specific hardware and use case. We allow these companies to really solve their ROI calculus. Now Shopify can rewrite every single query without having to send a query to someone's data center and wait a second, without having to reveal all their user preferences, right? Without also having to eat all that cost. Same thing with Mercedes. They can handle all these use cases with the hardware already in the car without violating your trust as a consumer, and maintain their ROI.
And I think to thank you for clarifying that. And I think that my guess is this ROI problem is something that many companies, of course, are aware of. But I think the problem will become even more relevant and understood as the quote great AI subsidies start to end. Right? We've seen a story recently that it's not a well kept secret that a lot of the plans that Anthropic and OpenAI have had, they're losing money on. Right? There are so many power users are just like absolutely torching their budgets for token use. And so they're operating at a loss, more or less. And at some point, if and when the pricing catches up to more accurately align with what users are doing, they'll see, oh my God, we're spending a lot of tokens for these queries. And to be more explicit, as you said, every query is like going effectively to data centers, and that's burning more energy. And so the models themselves, the size, let me know if I'm getting this wrong, but these literally large language models often have way more context and, in some sense, in a way, bloat than a company might need, right? So as someone once described it to me, if you're a law firm and you have use cases for analysis for like tort law, does your model also need to write beautiful French poetry, right? Do you also need to be able to create images of your Kevin Durant shoes, right? So like often people are paying for massively more AI than they need, which has an impact on cost and also performance and speed. And it might be kind of hard for an individual consumer to see because like, whatever, I pay $20 a month on ChatGPT, it's fine. But when you're operating at scale enterprise and you're having to crunch the numbers, and it only kind of sort of makes sense now, but then if the costs go up a lot higher as the subsidies end with these models, that ROI gets a lot trickier and harder to defend. Am I warm on all of that?
Absolutely. That's absolutely what we see and what we agree with. And what we see is, again, I don't think it's not a knock. There's a time and place for all this technology, right? Like what we see with our enterprise customers and partners is for use cases where 1 year ago they were happily using APIs that were sending their queries to these data centers in the cloud. They're now starting to realize, okay, to make the ROI make sense, especially as what you said, this subsidization of the tokens is going away. It's important for us to own our own models. And so you see companies like Cursor and you see companies like Mercedes all trying to train their own models and move away from the cloud. But it's not that they're not trying to stem the cloud. At the same time, you see Anthropic and OpenAI's revenues going up. It is more, the industry is realizing it's not a one-size-fits-all solution. And there are times and use cases where you need intelligent models in the cloud, like knowledge work, research, coding. But there are times where, for example, tort law, reviewing contracts, and it's the same clause every time, looking at every single product image on an e-commerce website and analyzing, what's in that image. You don't need, and it doesn't make sense to pay for all that weight, and you need a specialized model. And so we see this trend happening. And what we're also seeing, and this is most critical, is it's really hard to make a specialized model that works.
Yeah.
I think this is what a lot of people are running into firsthand.
Before we get to kind of solution mode, I want to spend a little bit of time on the larger macro challenge with the current thrust of effort and energy, literally energy, being poured into the large language model approach with data centers. Talk a bit about what you see as the kind of the problem with the stubborn math of, all right, if we're going to keep building at this pace, keep building more data centers, putting aside the political realities of can those even be built given how polarizing it's being. There's the environmental impact, the energy impacts. Is there even enough capacity question? How are you thinking about all of that?
Yeah, absolutely. We think that efficiency and usage of the silicon and the energy that we have today is just as important as it is to manufacture more of it, right? When we look at the world creating more data, creating more energy, creating more data centers, it's a positive sum way of thinking. At the same time, we only have one Earth and a fixed amount of resources, right? And so it is a bit zero sum as we see things like the RAM prices for consumer electronics, spike, and now the gaming community is impacted. These kinds of things have ripple effects. So we see energy being pulled in to data centers, sitting in rural or suburban cities that are impacting the energy costs of homeowners around them. And what we want to introduce is this idea that it doesn't have to be that way. Right? We can also have this ability to just increase our efficiency. And so what we think about is not only how do we build AI that doesn't need data centers to run, but also how do we build AI that doesn't need as much compute and energy to be used. And what we see from that is actually extending the effective life of the existing resources we have. One common thread people will talk about is, hey, today's GPUs in 3 years, no one wants anymore. Right?
Yeah.
But in practice, I think what we're seeing is there are certain companies who are focused on this efficiency, us being one of them, DeepSeek in China, famously being another one, that are able to push the frontier and bring real economic value to the world, state-of-the-art functionality to the world, while extending the shelf life, the expected shelf life of hardware and resources you need to create models. And I think that's valiant, important, and prevents us from being so wasteful.
As you point out, Jeffrey, it's not easy to build these small models. Without getting too in the weeds here, give us a sense of the kind of foundational technology that you guys unlocked like years ago, right? So my understanding is that Liquid, that the roots of Liquid go back well before the current Gen AI boom. I think it's important to acknowledge you guys are not just like oh cool, we're gonna do this because it's a fad. This is the deep tech goes back a ways. Talk about what that kind of the key innovation was, and then how it's informing your latest crop of models.
Absolutely. The key, so the company was first originated 7 years before the company was founded, when our co-founders met at MIT's Computer Science and AI Lab. At the time, there was no ChatGPT. There were no generative models. There were AI systems that were doing predictive tasks like hot dog, not hot dog from Silicon Valley, but also trying to steer a car, right? And what our founders at the time sought out to solve was asking themselves, even though the then state-of-the-art machine learning models were capable of doing things that we had only dreamed of before, they were far less energy efficient than humans. Biology can do so many interesting things with a fraction of the wattage and energy that these machines need, right? So how can we look and analyze bio and try to figure out how we can bring those learnings into the computational sphere? Because if you can do that, it's not just about ROI. You can start to innovate at a faster pace without being bottlenecked by the hardware and metal and silicon you have in the real world, right? So that was what they really focused on. And at the time, coincidentally, actually, 10 years ago, I was doing biotech research. This was when CRISPR just came out, which was a gene editing protocol. And one of the first candidates for this gene editing was either plants or these tiny microscopic worms called C. elegans. And what's interesting about these C. elegans worms is basically they're so small that we actually successfully, as a human race, were able to sequence their entire genome. We just understand everything about this genome. And so you can do interesting things with them. So while I was doing bio research on these worms, turns out these founders were looking at that genome and asking themselves, how can we take inspiration from this into the machine learning world? And so they were working on different research ultimately led to novel types of, let's say, Legos and building blocks by which you could construct alternative machine learning models that are still capable, but try to learn from and bring some of those structures and bring that bio-inspiration in to create more energy efficiency. And what happened 3 years ago when this company was founded was, as the influx of generative AI shot up and this transformative adoption to society manifested, and we saw the massive increase now in energy and compute actually materialize, it felt like the right time to take this technology and now apply it to one of the most transformational, but also the most data inefficient and energy inefficient technologies out there, to basically accelerate the innovation pace that we can do, and also widen the number of use cases that are ROI positive.
And what's the name of the foundational technology that the co-founders developed a decade ago? What's the name of that exactly?
Yes, the technology they developed a decade ago was called liquid neural networks. So
Great.
at the time before they invented this, there were neural networks. Neural networks were able to, they're the fundamental technology that allowed computers to see the computer vision work we were doing at Snapchat. The same technology that allowed computers to understand the text on the screen. And they were very rigid, and they were non-expressive, and they were compute hungry. And because the co-founders were able to take this bio-inspiration and make them more adaptable and more efficient, they named it aptly liquid neural networks. Same functionality, but more adaptable, more energy efficient, et cetera. Today, the company is called Liquid AI because we've taken that same principle, that same approach, and now we're applying it not just to neural networks, but to modern day AI systems as well.
Awesome. Let's come up for air a bit and get into kind of use cases and what this actually means for people, for consumers, for businesses. You mentioned earlier a few different use cases. And if I can take a stab at synthesizing this, the idea is that if you were to use a big, massive model that might be a lot of horsepower, but it's hard to deploy on specific devices at times, because do you want to pay the cost to ping the data center a query each time? Whereas if you have some literally a local, hyper local system all in one device, it's faster, it's cheaper, has less of a footprint. So A, am I getting that right? And B, what types of use cases are possible now by using Liquid that would otherwise be far more complicated? And then you mentioned the Mercedes deal that you recently signed. What are some other kind of actual deployments and partnerships you guys already have and are working on?
Absolutely. So first, yes, you're absolutely correct. Not every use case needs to phone home with the largest, most capable possible model, right?
Yeah.
Case in point, I'll give you a bunch of use cases right now off the top of my head that make our lives easier every single day, that when you think about it, make no sense to send to the same model that people are using to solve cancer, right? For example, autocorrect. When you go into your email client and you're typing a sentence and they correct it, or they smart guess the next couple of words you're about to write, right? Or you ask it to rephrase it. Do you want that across every single surface, whether it's email, your text, your calendar, your notes, your voicemail, to be sent to someone else's data center? Do you want to wait for several seconds? Do you want to incur that cost? Do you want to sacrifice your privacy? Multiply that across every single bit of user data on your phone, not just the data you're inputting, but the data that's there because it's in your photos, right? It's in your calendar. It's in your health data. Is that something you want, both for as a consumer for the privacy, but also the reality is this is incurring costs in the cloud. And even if you don't think you're paying for it, you are, right? It's either baked into the hardware or it's baked into some kind of flat fee subscription, or you're paying for the tokens. We believe we shouldn't limit the pace of innovation to the features where it makes sense from a economics perspective to run in the cloud or to run on a data center. That doesn't make sense to us. So yes, I agree with what you said. In terms of what is possible in the case studies.
Yeah, go for it. Yeah. So what are some actual concrete examples of things that we can do now that would be not realistic to do before?
Fantastic question. So one thing, for example, is proactive AI. What does proactive AI mean? It means AI that does things before you invoke it. Now, think about what this means for a second. When you drive your Mercedes car today, As you're driving, you can say, "Hey, Mercedes," and it'll start to listen to you. "Give me the directions to the closest Costco," and it will route. That's reactive AI. And there's a bunch of that out there. That's really good. What is proactive AI? Proactive AI is AI that watches you, understands your intent, and takes action for you before you even ask for it. So this might be you getting in the car, you're sweaty, you just had a sports practice, you're tired, outside is incredibly humid, the interior car is very hot, and the car realizes it sees this and sets the temperature to the temperature it knows you like the most and points it at you. Right? How do you do that?
More benevolent. It's a more benevolent version of, I was thinking, my first thought is, oh yeah, like Minority Report. It knows I am thinking about killing someone. And so it will handcuff me before I kill the person. I'm teasing. Obviously, you guys are not trying to build some precognition arbiter of morals and ethics. But what are some other examples of a useful ways this can kind of like anticipate your needs and address them before they even happen? It's very cool.
Yeah, fantastic. Imagine if every single person had their personal EA and executive assistant, a chief of staff at work. Imagine if someone could watch everything you're doing on your laptop as you work throughout your day. They could look at your screen, they could look at your face, they could go through your notes, they could think through your email and take actions for you and make your life easier for you without you having to tell them to do so, right? That's an example. Imagine same thing. You're in a smart home and all your appliances are able to learn your preferences over time and take these actions for you, such that when you wake up, the coffee's ready, etc. These kind of proactive AI features, why are they not possible in the cloud? It's because if in a reactive AI setting, the AI is off until you ask for it. In a proactive AI setting, the AI is always on, always observing, always thinking and reasoning, should I do something now? So even if the AI only actions once an hour, it's thinking every minute, every second. And that consumes an incredible amount of cost and violates an incredible amount of data privacy if you're streaming all of that to a data center. But when it happens on your device or in your home setting, there is zero latency, there's zero data privacy, and there's also zero compute cost because it's running on the hardware you already have.
Couple of quick follow-ups there. One, on a kind of prosaic one, I'm guessing this is hyper relevant to folks who are dabbling or quite serious with their AI agents or even OpenClaw-esque agents that are on all the time, right? More and more folks are using a Mac Mini. I'll show you for those of you watching on YouTube video, here's my Mac Mini right here, right? So I'll be having my Mini, which will have all kinds of agents on it at all times, right? So I'm guessing that this makes the cost of that more manageable, right? Because one big issue, if you have constant API hits from your agents nonstop, that might be doable in the world where we're being subsidized. When subsidies goes away, that'll go through the roof. Well, let's start. I'll pause there. Your reaction to that. Then I have a bit of a more philosophical question for you.
I absolutely agree. I think with these agents, they're agents you can ask to go do things. But what if the agents could do things for you? What if they could preempt your needs, right? What if your agent could learn your preferences, still be safe, but understand what you needed to do? Life would be better, right? And in order to do that, the only way that's possible, again, in a data secure way, in a unit economic positive way, is to bring that inferencing locally to your device. And that's really hard. And that's what we try to solve.
So the more philosophical question, and this I know this is not like why you guys are building Liquid, but I'm guessing many listeners, when they hear this, some will be excited and some will be a little worried, like, do I want AI like staring at my face and trying to guess what my mood will be in 5 seconds and trying to assess my mood? There is, I think, some level of anxiety that, hey, this is like overly invasive. You mentioned privacy concerns in there. Would love to hear you kind of expand a bit on how you address the privacy concerns. But and there's also, we recently had a conversation, this podcast with Carissa Velez. We had a TED Talk about the sneaky and surprising possible dangers and downsides of AI fueled predictions, right? And that was, I think, is a little more about society level. Like if we're predicting who should get loans, that might actually change who gets loans and hurt people, right? But maybe it's different from a user basis. But long-winded way of asking, how are you thinking about the complexity and challenges of kind of AI that's like moving 3 steps ahead of you and predicting your behavior, and how users might be squeamish about that?
You're asking a great question, and we actually think about that a lot internally. We think that data privacy should be a choice, and you should be able to have AI along the entire continuum of how much privacy you want.
Yeah.
The reality is today we don't think it is. Today, you either, and similar to social media, you either subscribe to sending all your usage data to the cloud for someone to train on, or you don't get AI. And that's difficult, right?
Yeah.
So when we think about these experiences and bringing AI in a smaller footprint, what that unlocks is bringing AI local to you. That means it's trustless, right? That means your data doesn't have to go anywhere. It does, and it means that instead of sending every single thing about your AI usage to the cloud, you can keep it with you. You can trust an AI that will only ever sit with you, can run with the internet off if you really want to make sure it's not sending anything to anywhere. And it gives you the control of when selectively to pass data to the cloud. So one common use case people actually use our models for is instead of talking to ChatGPT directly, they might talk to a liquid model running locally directly. And the liquid model, similar back to what we're talking about in the beginning, type 1, type 2 thinking, might be able to handle 80% of requests with type 1 thinking. And for the type 2 ones, it might say, this is a good time for type 2. And I'm going to help you redact all your personal information from this query before I send it to the cloud. And so these kind of things we actually think help give people more fine-grained control of their data privacy. We see preferences change by industry, preferences change by person, preferences change by geography. That fine-grained control, I think, is very important. And that's a common use case for the technology that we're inventing. The second point you brought up.
Yeah, go ahead.
Sure. The AI field predictions. Loan underwriting, fantastic example. We can double down on that one. In a day and age where we have GPT and Anthropic and Claude, loan underwriting is still supported by ML technologies from several decades ago.
Yeah.
Right. And when you think about why, it's because of consumer protection. It's because in the US, the financial systems and the regulators say they're protected classes. We have to make sure that when loans are being underwritten by technology, that we're being fair, we're being equitable. We are not penalizing people for protected classes, right? And that means that any kind of ML prediction system has to be inspectable. I have to be able to look inside and understand why it made the prediction it made. And the trends that have happened in machine learning over the last decade have shifted from a more mechanistic approach that's very inspectable to something that we call deep learning, where it's more of a black box. You no longer know what's happening. You trust that the computer figures out a better way to go from a user's persona to a loan. You can't tell why it did that, right? And so with these large models, yes, with these large language models in theory, yes, they can do great underwriting. You can ask it, what did you think? You don't really know what's happening inside, right? And so one way to solve that, but still bring in generative AI, is to actually decompose the system into smaller, specialized versions of generative AI. So what does that mean? That means instead of passing everything to a large language model and saying, decide whether or not to give this loan, you can still have fine-grained control over, let's look at this characteristic, let's not look at this characteristic, let's weight these in this way. But for each analysis you do, you can bring in the power of Gen AI. So maybe that means, hey, I know I don't want to, let's say, look at ethnicity, but I do want to look at their effective credit and how well they paid off, credit cards and things like Klarna and Afterpay. Yeah. You can have a specialized model just look at that information, right? And we believe that actually by containing these things and giving the humans the ability to create these separation concerns, you allow people to kind of choose where they want to be on this continuum of mechanistic, very interpretable legacy systems and black box, deep learning systems in the cloud that are amazing but uninspectable. We believe we can introduce this middle paradigm that gives humans kind of more control over that prediction and allows them to selectively introduce the power of new AI without being, without having to resign themselves and their agency to these black box systems.
As we wind down, last couple of questions for you. You alluded to the Mercedes partnership earlier. Can you say a little more about that and kind of what specifically kind of use cases are you helping Mercedes with, and how will future Mercedes drivers, how will it feel and look different thanks to what you guys are building?
Absolutely. Mercedes has always been a brand that focuses on being first and best in class from a driver experience perspective. Anyone who's owned a Mercedes or been in a Mercedes knows that the interior cabin experience is top notch. And what Mercedes is very driven by is by asking its customers, what do they want that we're not doing a good job at? And the resounding answer from JD Power was the in-cabin audio assistant. When you ask Mercedes to do things for you as your hands are full, like turn on the windshield wipers, navigate me to this place, call my mom, right?
Yeah.
I'm feeling a little bit cold. It wasn't performing very well. It was very frustrating for people.
Mm-hmm.
And when people, use, let's say, the OpenAI or the Anthropic Claude chat experience on their phones, it's excellent. It works really well, but it's streaming it to the cloud.
Yeah.
And Mercedes had to think about, okay, great. How do we build a system that brings that quality that people expect from Mercedes and also from the experiences of having the cloud, but do so in a way that respects their privacy? We don't want to sell Mercedes cars that are basically just monitoring systems that send all your data to the cloud. People don't want to buy that. People don't want to trust that. And it wouldn't fly in Europe anyways. How do we build these systems that are ROI positive, such that we can build proactive features that make the experience more catered to you and more personalized, such that when you get in the car, I know the scent you like, I know the car you like, the colors you like, I know the music you like, right? And I can set that based off of if you're sitting in the front seat or if you're sitting in the back seat, or if you're being driven, or if you're busy and reading a book, or if you look energetic or not. How do I do all these things without incurring a ton of costs, right? That wouldn't make it possible to introduce these delightful features. For that, Mercedes realized they needed a different intelligence partner. They needed someone who could figure out how to bring the production quality people need, but run it inside the car platform of today. And Liquid is able to do that across several different use cases. And we're really excited later this year, we're going to be rolling out an upgraded audio assistant. So anyone who says, hey, Mercedes, and talks to their car in North America will be talking to a Liquid model running fully in the car, fully private, fully offline. We have many other exciting projects we'll work with Mercedes on, such as giving the car eyes inside and outside the car, et cetera. And also deploying onto things and robots they build outside of just consumer cars, potentially robotics, and in the warehouses, et cetera.
If it's helpful for you guys, to feel free to send a Mercedes my way, and just indefinitely, I'll test it for you guys. So happy to help with that. And so, last question for you to kind of make this a little more just to kind of put a bow on all of this, and to be very concrete and clear of how it could look and feel for the user. So, essentially, am I right, Jeffrey, that if you have something on your phone, if it's a Liquid powered AI, your phone could be on airplane mode and it would still work because it's not going anywhere. It's on that actual device, right? And then I guess the follow-up question to that is, where does this AI live, if you will? Like, where can talk a bit about kind of like the actual mechanics of how is it possible that you have like in some tiny device, it is running all of this and delivering this magic. It's kind of hard to get your arms around in a way.
Yeah, fantastic question. So the first answer, yes, absolutely. There are situations where you don't want to connect to Wi-Fi, such as you're dealing with privileged information, banks, hedge funds, biotechs, et cetera. There are times when you don't have Wi-Fi, right? You're on a flight, you're driving through a forest, et cetera. There's a power outage. There's times where Wi-Fi exists, but it's not for you. Let's say you're in a foreign country, right, where there's monitoring, or you're afraid of foreign adversaries, or you really care about sovereignty. These are all reasons where, yes, you would need a model that can run without dependence on the internet, and absolutely the Liquid models can do that. Where are they running? Well, they run on the silicon in the device. I think people today think about, we need huge GPU data centers in the cloud, right? GPUs sitting in someone's data center that we access via the cloud in order to run AI. And how could a phone or a laptop or a car possibly run AI? But we also have to remember that the compute in these devices is exceptional compared to where we were 10, 20 years ago, right?
Yeah.
We're able to run like computer programs and technology that we never thought were possible. And so it's a matter of time, not a matter of possibility, to run cutting edge AI on the hardware that we have outside of data centers. And we believe that in order to accelerate that and make that a reality, we have to really build technology that can fit on those chips. And so that's the difference that Liquid takes is we say, look, if there's a model that has to run in a Mercedes car, what is the hardware in the car? Mercedes is not putting a data center, even a tiny data center in every car, right? But they do have compute in the car. What is the compute in there that is available to deploy AI on? And what does it mean to almost tailor a model or, to use an analogy, tailor a suit or a dress to that chip and really maximize the compute that we have available instead of trying to cram a model that was built for a data center into a car. And I think that's the difference in approach that we try to take such that it can run on the devices that you have all around you.
Jeffrey, really enjoyed talking to you. Very cool you guys are building. Thanks for taking the time to break all this down. Thanks again. Really enjoyed it.
Appreciate it, Jeff. Thank you for taking the time.
Well, there you have it. Thanks again to my guest, Jeffrey Lee, COO of Liquid AI. Thank you to Jasper Chua, our producer and sound designer and videographer. Thank you to Bradford Craig for our show's theme music. And thank you to you, dear listener. If this is your first time at AI Curious, please subscribe, rate it 5 stars, all that good stuff. Thanks again, and see you next time.